All right, welcome to the PNOΗ Certification Series Level 2 webinar number 2 on respiratory training. And last week we covered isolating respiratory limitations through testing. I was able to show you the difference between a capacity and a capability limitation and what particular metrics we look to be able to isolate those. And today we'll be covering what do you do when you find them. So the first thing I want to do is prove to you guys that, first of all, that respiratory training works. So in this study from April of 2000, it indicated it was a review of the science on respiratory training, and they found that studies indicate that exercise does induce respiratory muscle fatigue, and that respiratory muscle fatigue can limit exercise performance, and that endurance of respiratory muscles can be trained, and that respiratory endurance training can enhance endurance exercise performance, even in healthy subjects. So that's the first thing I want to do is just spend a little bit of time explaining to you guys that this has been well proven and it works well. In the same study, just an extension of that, they found that changes in breathing pattern that occur with increasing exercise duration, possibly because of respiratory muscle fatigue, include increased respiratory frequency, hyperventilation, and or an increased sense of respiratory effort, and they are reversed either completely or delayed after respiratory endurance training. And then just to back that up, I brought up an article from 2015, and the article's title was "The Effects of Inspiratory Muscle Training on Resistance to Fatigue of Respiratory Muscles During Exhaustive Exercise," so the high intensity exercise. And this study found that in healthy subjects, inspiratory muscle training, IMT, results in significant increase in the maximal inspiratory pressure, or MIP, by 18%. And that is essentially the pressure that is created on the deep breath in, and a delay of inspiratory muscle fatigue during exhaustive exercise, and significant improvement in maximum work performance. And they concluded that IMT elicits resistance to the development of inspiratory muscle fatigue during high intensity exercise. So there's lots of research showing that that inspiratory muscle training works. There's not very much on expiratory, and I think that will be the next move here is now that devices are doing both inspiratory and expiratory training, I think you're going to see quite a bit more research being done on that, because I find in a lot of cases people's FBC6, so their forced vital capacity, is actually pretty good. I find the largest limitation is in their 1 second expiratory volume. People just cannot breathe out high volumes quickly, and that tends to be a lot of the restrictions, respiratory restrictions that I see. So some of the benefits of respiratory training include a substantial increase in endurance and performance, a noticeable increase in general physical fitness, improved peak performance under stress, and shorter recovery times during and after competitions and training. This gentleman in the photo is a fellow I trained for climbing the Himalayas, and I got him to do all of his training. I did all of his tests, metabolic testing, zoning, and had him do all of his training mainly on a Stairmaster. And he had a respiratory limitation that I figured would really limit his ability to be up at that altitude and be able to do the work day after day after day. So we did respiratory training with SpiroTiger. On his trek, he was the only one that wasn't Sherpa, that never got altitude sickness and was capable of doing day after day. He was capable of keeping up with the Sherpas while everybody else was sick or suffering with respiratory limitations. So a very interesting use of respiratory training to prepare people for being able to work at altitudes and keep their respiratory endurance high enough to be able to work day after day. Other benefits of respiratory training have been proven to be improved endurance of the respiratory muscles, optimized oxygen supply to the skeletal muscles, so the delivery side, faster return to homeostasis during and after stress, so a better control over acidosis, improve coordination capability of the respiratory system under stress. And coordination, we tend to think of as a combination of the breathing frequency and the volumes together. So that's what we would consider more coordination. And it also does a lot of strength in the neck, abdomen, and back muscles. In fact, it's one of the best postural exercises out there is respiratory training. And it really does help develop your abdominal and back muscles themselves. In fact, a lot of people, when they first start working with Spirotagger, if they have a thoracic limitation or a low back issue, they often have complaints of increased soreness in those areas. That goes away with time. Now, this is another one of my athletes, a high-level runner who desperately, she tried for 6 years to try and break a 3-hour marathon time. Could not do it. Came and saw me. I tested her. She did really well in everything except for one thing. I felt that her low-hanging fruit was respiratory. She did about 2 or 3 months of respiratory training prior to Boston, and she actually finished in 2:55. And that was something that she worked with multiple coaches with multiple training techniques, and none of it worked except for the application of respiratory training with Spirotagger. And this is the device that I work with most of the time when I'm doing respiratory training, because it gives me the most options of being able to use the device for various reasons in respiratory training. So I thought I'd present to you some current training methods that are out there. And there's quite a few resistive devices, meaning that they actually have a method either through the flange or a method by looking at the pressure of you breathing in and out. They're able to provide a restriction to the airflow. And that restriction to the airflow is what strengthens your muscles, whether they're inspiratory or expiratory, depending on the device. So if we look at this, the Power Breathe from this line, it provides resistance on inspiration only. So it does not train expiratory capabilities or capacity. There's a limited number of breaths that you can do per training session. So what they recommend is approximately 30 breaths in a session, in a training session, twice a day. There's no carbon dioxide monitoring, so you can't tell whether you're becoming hypocapnic or not. There's no ability to adjust volumes or breathing frequencies. You can, but there's no way of adjusting the machine to do that. And my biggest issue is resistance limits volume. And if you want to do respiratory training specifically to increase your capacity, then you need to increase your volumes. And as soon as let's say the person is only 80% of their FVC, all of a sudden, if you put a resistance against that, they're lucky if they're going to be able to maintain the 80%. So what you're going to do is get them more efficient at breathing more poorly. And there's some advantage to that, I guess, but if your real goal is to actually increase the volume, then these devices aren't necessarily the best. The other thing I have issues with this is 30 breaths twice a day. A lot of these devices require you to take a break because of the fact that there's no kind of control over CO2 and O2. And therefore you'll become dizzy and you have to stop. But unless you're, a lineman in football where, there's only 30 breaths in an effort, this doesn't really apply well to many of sports, especially the endurance sports themselves. So I have real issues. I've used the K5 before. I tested it out. It has some cool stuff to it, but I really don't find that it's extremely beneficial to being able to increase volumes. As a resistive device, if you want to gain strength, let's say you have good volumes and you want to gain strength, then especially on inspiration, but not on expiration, then you could use it. But then again, as I stated, most of the restrictions I see are related more to expiration. All right, another device that's out there, this is one's relatively new, is called the AeroFit. It does provide inspiratory resistance with a valve between A and F for resistance, and out between 1 and 6 on this side. As you can see, there's no other devices. There's no CO2 monitoring. There's no ability to be able to adjust volumes or breathing frequencies. In other words, it will just read what you're breathing. It won't get you to try and breathe more air. And then, of course, resistance, again, as I stated before, it limits volume. So if you want to increase your FVC or your FEV1 volumes, then using a resistive device does not make sense. If I go, let's see if I go back up, you can see the price ranges I try to provide in there, 29 pounds through 500 pounds. These things are not cheap, especially if you want to get any kind of electronic feedback. On this one here, it's about 255 US. And like I said, this is relatively new on the market. And if you're just working strength and you have good volumes, it may be a good option because of the fact that it works inspiration and expiration. All right, so there are quite a few resistive training devices on the market right now. So in this case, we're looking at the Power Breathe, which has a range of prices between 29 pounds and 500 pounds. With the K series being their electronic series with some measuring capability as well as training capabilities. The issue that I have is that it only trains inspiration. And a majority of the limiters that I've seen within my athletes have been mainly expiration. Sure enough, there's some people with poor forced vital capacities or volume. But in a majority of the cases that I see, that they just can't breathe out the volumes that they should as quickly as they should. And these devices do not train it. There's also a limited number of breaths per training sessions that they recommend. They recommend 30 breaths twice a day. And of course, that does not translate to endurance sports well. Like being able to do 30 breaths may be okay for an offensive lineman in football, but it certainly doesn't equate to doing a half marathon or a marathon or a triathlon. One of the real deficits of here is there's no CO2 monitoring. This is part of the reason. Without CO2 monitoring, they can't tell if you're becoming hypoxic. And that's why they limit their training sessions, is because of the fact that you can only breathe deeply so many times before you become dizzy, and because you're changing the biochemistry in your body. There's no ability to adjust volumes or breathing frequencies. It's in particular breathing frequencies, you have no real control. You can breathe at any frequency that you wish. Therefore, there's really no control except for being able to apply the resistance and breathing as hard as you can. And sure enough, that will increase your strength. But the problem is when you add resistance, it'll limit the volume that you're capable of moving. If you could move 2 liters without resistance, by adding resistance, you're going to be lucky to hang on to those 2 liters, but you'll become stronger in that range. So what will happen is not only will you be lucky if you maintain your volume, but you'll actually stiffen up the diaphragm by working excessively in that range. And that's a real deficit of the Power Breathe product, is the fact, again, it doesn't train inspiration or expiration, and it is only resistance. That's all it works on. When we look at the AeroFit, it's another resistive training device. The good part about the AeroFit is it does train inspiration on here with 6 different settings, and expiration here with 6 different settings that you can dial. Again, there's a really limited number of breaths per training session. They recommend maybe 5 to 10 minutes twice a day, which again doesn't transfer well to endurance sports. And the resistance still blocks your ability to move volume. So if you have a capacity issue, it's not the right device for you. If you have good capacity, but you lack some strength, then it may be a good option for you. There's no CO2 monitoring, and there's no ability to adjust for breathing frequencies. So you're going to end up just being stronger at the frequency that you train at. And this is a real issue. We want you to be able to move volumes at certain frequencies. And that will cause a proper application to your sport. And this one is about 255 US. If we look at another resistive device, Power Lung's been around for a long time. It's relatively cheap. This particular model is about 120 US. It provides resistance on inspiration and expiration. But as you can see, it's very simple. It's based upon springs, and you can adjust the increase or decrease the resistance here, or you can adjust the volumes through here. But really all you're doing is breathing through a resistive spring device. And that's why it's cheap. There's no CO2 monitoring, no ability to adjust volumes or breathing frequencies. You're basically just adjusting your resistance and working against that. Whereas if you look at SpiroTagger, this is the device that I mainly used for the last 15, 18 years. This is a SpiroTagger Go. As you can see, there's a bag on the end. We changed the bags for between 2 liters and 6 liters. Believe it or not, there's people who were breathing 6 liters. And then on the screen, there's the ability to adjust there's a metronome that you can adjust for breathing frequencies that you can prescribe in your programming. So I would prescribe you a volume decided by the bag, and then breathing frequencies, which you would follow the metronome on inspiration and expiration. It's a central unit with the user set, which consists of the mouthpiece, nose piece, the black pipe, and the bag. So other people could use the main unit by simply buying a user set and then just exchanging the main unit itself. There's some of the limitations are there's no CO2 monitoring on it. There's no direct volume measurement. There's nothing measuring the volumes through here. The breathing frequency is measured through a magnetic system inside, but the volumes are assumed based upon the volume of the bag. There's no limited, I apologize for that. I need to fix that slide. There's no limited breathing sessions. You can you can train inspiration and expiration without resistance. And some of my guys will be working 30, 60 minutes at a time, depending on the training program itself. So again, this one it's no resistance on the inside. It's just strictly volume and cadence of your breathing, and being able to control both of those components to be able to decide whether I'm working on increasing your volume or whether I'm working on your coordination or getting you to be able to use volumes at different breathing frequencies. And some of my training plans would last 20 minutes and some would be 30 and 40 minutes in length. So there was no limitation on the length of time for the training. What I like about it was, like I said, it was a single user or multi-user. And we'll go into that a little bit more because financially they were about 570 US. They're expensive, but you could unplug the user set and you could use the central unit with people 5, 6, 10 times a day. They would just come in and screw their piece in and do their training, plug their training program in and be able to use the device. So these are some of the current training methods. I'm not even going to talk about, people putting masks on their face to make it more difficult to breathe and calling it an altitude trainer. It's absolutely ridiculous. So I'm not even going to even discuss it. We'll move on to the next. One of the ways of looking at every one of our training methods have different variabilities variables that we can adjust. In this particular case, the variables that I want to discuss are volume. We can adjust volume, which is based upon capacity. We can adjust strength, which is based upon capability. We can adjust endurance, which is based upon capability. But we could also look at coordination, which is based upon a combination of volume and breathing frequency. And when we're doing our training programs, we can also adjust their position. Are they in sitting? Are they in standing? Are they in a split kneel? We can add challenges by adding a balance challenge, for example. We can also make it sport specific. Can they do this while on a bike in a proper cycling position? And also other training variables that we can use is using the device for pre-race preparation and post-race recovery. So there's all of these aspects to using the respiratory training device that these are all things that we can adjust, just like any other modality of training. Now, on the Spirotagger, what I used was generally, once I looked at their frequencies, if they were hyperventilating in certain zones, I would be able to use that as a variable to be able to adjust. I would work, if they had a capacity issue, I would work on volume and make adjustments from that. When I worked on volume, I didn't care about frequency. All I cared about was getting the proper volume in. Afterwards, we had to turn it into something that worked during the sport. So we would apply volume with frequency and we put them together. We would add or take away accessory movements. If the person had, let's say, lacked thoracic mobility and rib mobility, then I would throw in accessory movements of the chest and thoracic spine to be able to mobilize with each breath. So on their inhalation, I'd get them to move upward and backward, bringing their elbows high on their breath in, and I get them to bring their elbows down on the breath out. And what that would do is mobilize their spine into extension, and the ribs into extension, and the ribs into flexion on inhalation, thereby increasing their spinal mobility. I would do positional changes once they were good and a more stable, like taking away all other challenges to the trunk. Let's say sitting in an elbow prop position, that would take away all the other jobs of the diaphragm. Then I might bring them into an upright sitting and then move them into a standing position. So using these different position changes to be able to say, okay, now I want the diaphragm to be able to stabilize the spine and be able to breathe at the same time. Then we look at facilitation versus resistance. Do we want to facilitate the muscles they have versus add strength to them? So they may have very good strength, but they don't have the ability to get the neuromuscular coordination to be able to facilitate the muscles they have as well as they should. So what you would do is you wouldn't add a resistance to it. What you do is get them to train repetitively to learn the movement well. And you can add balance challenges in if it's, let's say it's a trail athlete that's constantly working on different cambers and different surfaces. You can add a balance challenge into that. I use the 4-4 matrix, which is actually from the SFMA, Selective Functional Movement Assessment. And this is the order that they use when they're applying exercise. Let's say it's a chop or a lift. These are the positions you would move the person through to ensure that they learned how to do the exercise well and adapted well. So what I do breathing with my people in prone and supine, not athletes, but if I had somebody with COPD, sure. Then I'd move them into quadrupeds, in other words, on all fours, and get them to try and be able to breathe there. A little less spinal stability from the floor, a little more work as a stabilizer for the diaphragm as well as for breathing. Then you can move them to a half kneel and a tall kneel, and then into a full vertical position in the standing. And then you can add the balance challenges on top of that. So this is one of the variables that you should always be thinking about with respiratory training is what position should I start them in to make them most successful of achieving their goals, be it a capacity issue, or a capability issue. So going back into that, natural segue right into reminding you guys that capacity limitations refer to when an individual's lung volume is reduced below what is normal for his age, gender, height, and race, using direct measurement, preferably spirometry, or we can use comparative data, but ideally spirometry. So on that capacity side, we identified that there's two types. You either have an inspiratory capacity limitation, and we find that out from your forced vital capacity, the amount of air you're able to breathe out after a deep breath in 6 seconds. And then we also look at an expiratory capacity limitation, how much comes out in that first 1 second of your FBC, and that would look at your expiratory volume. So if we stick with capacity and we think inspiratory, expiratory, we want to follow down that line. So capacity training is volume training. I can't keep repeating this enough because there's so many people using resistive devices to increase volume, and it does not make sense. They have a role, but that's not it. So as I stated, resistance devices restrict volume, they increase strength, but limit volume gains. You get better at breathing at your current volumes, which is not the goal of their training. And you must allow the athlete to move the maximum amount of volume per breath at any breathing frequency. So breathing frequency is not an issue either. So you throw out those two variables. And once capacity goals are achieved, you move immediately on applying it with a capability goal. Whereas a capability limitation refers to when an individual can't use his capacity, available volume during a graded exercise test. So going through that again, we identified 3 different types, a strength, an endurance, and a coordination limitation for capability. Now, how do I know which one of these training programs that I should do for a capability limitation? You know, how do I identify that from the test results? So if the person has a capability or a capacity issue identified in the spirometry, they will get volume-based training. So everything will be based upon a volume with no resistance and no requirement for maintaining a breathing frequency. That's it. The workouts are intense, so they're shorter and extremely difficult with larger rest periods. They tend to be like 4 to 5 sets of 5 minutes. And you constantly pushing up the volume. The volume becomes the load for that person. And once you achieve it, then you move to a capability limitation exercise prescription. I hope that makes sense. So I'll show you how, and all of these are tethered at PNOΗ. I built these so that if they end up being a certain type of limitation, they'll be prescribed the right respiratory training program. So let's look at capability limitation type 1. This is identified during exercise tests, and it's based upon a percentage of their FEV1 from the capacity test or norms. So we look for a certain percentage of their 1 second volume from their spirometry tests or comparative to norms. The question 1 is, can they achieve a good VT or tidal volume at 1 or more intensity levels during the test? I don't care where it is. Can they do it at least once during the test? Showing me that during exercise, they can actually breathe that volume. This proves they can move the volume appropriate to their FEV1 and they don't have a volume issue specifically. If yes, you move to question number 2. And this, of course, your capability limitation type 1 will be part of the respiratory fitness score. If the answer is no, at no point during the exercise test were they capable of moving an appropriate amount in their tidal volumes, with a normal capacity, because of course that has to be the requirement. They have normal capacity, otherwise they're doing capacity training, not capability training. We would initiate respiratory strength program. So the issue is they were capable of doing it once through it. We need to increase their strength so they can do it through the entire through the entire test and at all intensities. So they've proven they have the volume at least once. Then what we do is respiratory strength program. I hope that makes sense. So let's move on to the next one. Question number 2. Again, it's identified from the exercise test based upon the percentage of FEV1. Can they maintain good VT throughout the test? So what changes now is we're looking, could they do it once in question 1, or could they maintain good VT throughout the test? And what we've proved from that is they can move a volume appropriate to their FEV1 at all intensities. We know they have the volume. So if they can't, we initiate a respiratory coordination program for those persons to be able to say, if you could move that good volume in zone 4, why were you using half that volume in zone 2? So we're going to teach you to breathe at the breathing frequencies that you should be using in zone 2, the volumes you should be breathing in zone 2. So the respiratory coordination program uses both volume and breathing frequency. And what we do is there are longer workouts where they have to try and maintain that volume at that breathing frequency and develop their coordination. Or if we find that they have really good volume for 2/3 of the test and at the end of the test they fall off, we could also prescribe them a respiratory endurance program, because they have the ability to maintain good volume for a period of time until they reach fatigue, and or they can't breathe that volume at that breathing frequency. So, and you can tell all of these things just by looking at the pattern of their breathing throughout the test. Now, what's interesting in here, what you want to be able to do is you just need to be able to look through their volumes all the way through. And we're building an algorithm that will actually find all of these things in order. Then if they make it through that one, they go in good. They've got good capacity, they have good capability. The last one is obvious. Oh, yeah, sorry about that. In order to be able, a few of you will be asking me, well, what is a good percentage of FEV1? So we'll use a range of 70 to 85% of FEV1 on spirometry, or we'll use the ranges of the norms. And in the norms, they give you a low range, a predicted range, and a high range, a high score itself, based upon gender, age, height, and race. And we'll reverse engineer it. In other words, we'll look at the volumes you're using, and we'll look to see if they are 70 to 85% of what your predicted FEV1 is. And therefore, if you don't have spirometry, we'll be able to do the reverse engineering of those numbers, and we'll be able to give you a score based upon whether you're near the lower linear number, the high linear number will get obviously a higher score, and the norms would get you middle of the road. But I'm telling you, spirometry is best. And to make this work in the app, you will be asked if you have spirometry measurements to input. If you answer yes, you'll be asked to enter the FBC6, and then you'll be asked to enter in the FEV1. And of course, you already have gender, age, height, and we're having a discussion right now whether we'll use race or not. And if your answer is no, then we know we need to reverse engineer from the norms. I hope that makes sense. So you should be able to move between 70 and 85% of your FEV1 on spirometry during the exercise test. And the reason why I use FEV1, just a reminder from last time, is that's your 1 second volume. At high intensities, you will be breathing between 50 and 55 breaths a minute, which is approximately 1 breath per second. So we use the FEV1 volume versus the FVC6 volume. And then of course, we need to look at capability limitation type 3, which will be based upon your breathing frequencies in each zone during the exercise test. So this one's all about breathing frequencies. So question 3, can they maintain good breathing frequencies in all zones throughout the test? And of course, you either are going to breathe slow, very rarely ever happens. You're going to breathe an appropriate amount for that intensity, or you're going to breathe too fast for that intensity. And so what we've done is we've had to come up with what we feel to be good breathing frequencies for each of the zones. And what ties with this is on the API, we have to have the ability on the pull down menu for you guys to be able to select zones. And we're adding that onto the API. So on the pull down, you'll be able to pull zones, and it'll drop the zones that we've calculated for you onto the main graph. Now, obviously, since these are related to breathing frequency, we use them for breathing and cognition score as well, because that's based upon hyperventilation. So it's, since we're going to be looking at your breathing frequencies. And if you do not, let's say you breathe, instead of breathing 20 breaths a minute to 24 breaths a minute in zone 2, you breathe 40 breaths a minute, we would actually put you on a respiratory coordination program where the focus is moving the right amount of volume related to your FEV1 at the breathing frequencies that you should in that zone. I hope this all makes sense. So you're probably wondering now, well, what is good breathing frequencies for each zone? And this is what we look at. I've used these for years. Yes, I've done this myself after looking at thousands of tests of my best athletes. Where do they breathe and what volumes do they use? So zone 1 is between 18 and 22 breaths per minute. Zone 2 between 20 and 26 breaths per minute. Zone 3 between 26 and 34. And zone 4 between 35 and 45. And zone 5 between 45 and 55 breaths. And zone 4 and 5, when you get used to looking at the breathing frequencies on the API, you'll see that they're never linear, they're never flat. They just go up through the whole effort and up through the whole effort. And that's why you kind of open up those zones, because you're going to go from top to bottom. And I don't want to average them. So I gave a larger range in that area versus a smaller range at the bottom, because everything's flat. So people are always asking, why do you have 4 and then a 6 range, and then you've got an 8 range, and then you've got 10s? That's the reason why, because there's a large variation in the breathing frequencies in zone 4 and 5, quite rightly, because you need to get rid of your CO2. So the new respiratory fitness score is now based upon 6 metrics. Now they're just building all of the back end on the API for this. They'll get 2 scores for capacity. They're inspiratory and they're expiratory, if spirometry is provided. If not, we reverse engineer their results. It's not as good, and I still strongly recommend everyone to invest in a spirometer. They're cheap, and it gives you so much more information about respiratory limitations with your clientele. Then you get 3 capability scores. Capability 1, again, VT at any point during the test, meeting 70 to 85% of your FEV1. You will score lower at the 70%, that would be the poor. 85% will be excellent. So the range will be provided there. Then we look at your ability to use that volume throughout the whole test, assuming that you got it on the first one, at least 1 point. And then we look at your breathing frequency by zone. And the 6th metric will be your VO2 over VF, which all of you will see will correlate beautifully with your respiratory limitations. You'll be able to find out exactly what zone their trend line of VO2 to BF falls off. It'll go up, 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 flatten out, and then drop off. And you'll be able to drop your zones on the top and say, this person needs to do respiratory training in zone 4 and zone 5. What volume should they use? 70 to 85% of FEV1. What frequencies should they breathe? They should be breathing in zone 4 between 35 and 45, so I would train them at 40 breaths. And at zone 5 between 45 and 55, so I train them at 50 breaths a minute at that point. The range that I use between 70 and 85% is based upon the fact that at higher breathing frequencies, it'll be harder to move larger volumes. So I give you a range of, if they're capable of hanging on to 70, 75% in zone 4 and 5 when they're breathing 40 and 50 breaths a minute, well done on them. It's an extremely hard workout. And hopefully you guys have been watching or listening to some of the podcasts, because I've been interviewing people that I have taken through respiratory training, and you get a chance to hear of some of their successes. Now, the future. Yes, I'm very good friends with IDAG. They are Spirotagger. This is what's referred to as the P100. It's the next generation of the Spirotagger. It does resistive and volume. If you want to do strength, all you have to do is press a different button and resistance is applied. Otherwise, you can use it for volume without resistance itself. It provides resistance on inspiration and expiration, unlimited number of breaths per training session. There is a CO2 monitor inside, which will automatically allow carbon dioxide to enter from an external bag where it's collected at the right rate to ensure that you maintain your biochemistry and you don't get dizzy, which allows you to work for long periods of time. It actually measures the volume of air. It's not based upon the bag size. It actually measures the air accurately as it travels through. It measures the breathing frequencies and the peak pressures that you're moving, as well as you can use it for an individual, or you can buy a user set, again, just the pipes themselves here and the bag, and if other people can use the actual expensive part of the device and just bring their own user set in. Now, it is expensive. It's 940 US or 860 I should say euro, sorry, not pounds. But absolutely unlimited abilities with this. You can use it for any type of respiratory limitation, and you can flip people between. As soon as you get rid of a volume issue, you can move to a capability issue right away. So I thought I'd show you a little video. Sorry, it's all in German. But this will give you an idea of the capabilities.
Der P100 ist der weltweit erste All-in-One-Atemmuskeltrainer, welcher ein individualisiertes Atemmuskeltraining für Kraft, Ausdauer und Intervall bietet. Er wurde mit führenden Schweizer Hochschulen entwickelt. Die konsequente Anwendung des neuen IDIAC P100 verspricht eine deutliche Verbesserung der Atemmuskulatur sowie der gesamten körperlichen Leistungsfähigkeit und kann bei Themen wie Abnehmen, Schnarchen, Atemnot und Rückenbeschwerden helfen. Der IDIAC P100 ist ein ergonomisches und in der Hand gehaltenes Atemmuskeltrainingsgerät. Das Gerät kann autonom über die Menüsteuerung auf dem Touchscreen bedient werden und gibt Feedback zur Trainingsanleitung. Die Trainings können zusätzlich in der App auf einem mobilen Gerät verwaltet, geplant und ausgewertet werden. Mit dem IDIAC P100 wird die Atemmuskulatur gestärkt und gleichzeitig die Lebensqualität positiv beeinflusst.
All right. A very impressive move forward for respiratory training. And I've made massive changes with my athletes, and some of my guys are at the top end of their game because of the identification application of respiratory training. So now I'm trying to be a little bit more helpful, as you know, since being in this game for over 20 years. How do you make money on this when it costs 860 euros to buy it? You can find your rich guys that you can do individual sales too, but you know, it's hard to sell. It's hard to sell them something that expensive. It's not a medical device, so it's hard to prescribe them through their medical coverage. We use a lot of guys that will have their own medical account that they actually, as a tax break, they put a certain amount in that they can spend each year. And we have quite a few people that have those accounts that buy an individual unit so they can train whenever they want, wherever they want. The other option, which I think is the best, is the training center, where you have 3 or 4 of these devices that are on the wall. The person comes in, you sell them the user set, they come in, they sign out the unit, they put their user set in, they do their training, and they give back the unit. And every time they come to your training center, they can do their respiratory training. And it's just a matter of building a booking system. And that way, in a very short period of time, because most people will train for about 12 weeks before they make their gains. And then, of course, like I said, they may make their gains in volume, but then you need to give them the capability of training to be able to apply it to the sport. So a lot of people, after about 3 months, say, no, I want this device. So I did a rent to own. That's another option, where they rented it for a certain amount per month. And then if they decided after 3 to 6 months, the money that they put forward for the rental was put towards the purchase. And that turned into a lot of sales in that particular case. And then the other side, of course, is continuing to update your training, getting them back in to be as part of their training. They need to come back in, let's say, in 8 weeks, redo their spirometry, redo their exercise tests to determine, number one, if their spirometry work is improved, so their lung volumes have improved, and has it applied to their function as far as their performance is concerned. It always does. It's absolutely wonderful to be able to see the changes happen if you prescribe the right exercise programming. And as I said, I've built it so you can't pick the wrong ones. And you adjust their training based upon their results. So perhaps they had a capacity issue. We found that went away through spirometry. You see all their VTs improving, but man, in zone 2 and 3, they're really not using their volumes, but they're still breathing too quickly. You'd move them on a coordination program for a capability issue, and you would set the parameters based upon breathing frequencies and volumes. Easy peasy. So that was the lecture on respiratory training. Obviously, there's a lot more about the individualized programs. I will actually start to put together combinations so you guys can be able to look at what does a strength protocol look like? What does an endurance protocol look like? What's a coordination program? What's an inspiratory versus expiratory volume program like? I'm now dabbling with the idea that perhaps that's what we should do next, but I'm waiting for my SpiroTiger P100 to come in, because I would like to be able to show you guys using that. So it's coming, the actual training programs themselves, and a demonstration of each type of training. So you'll be able to apply that. I would be interested to hear from any of you guys, if you feel that respiratory training is really an interest to you, and you would like to discuss it further with me about offering respiratory training at your center. I'd be very happy to discuss it with you. Like I said, I was one of the biggest sellers of SpiroTiger in North America. So I'm quite happy to talk to you about the do's and don'ts of of getting into sales on that side. But you need a response to identifying respiratory limitation. And I suggest that, that the P100 is definitely the best option